Hello students, this is Varun. In polynomial, last time we discussed about the division of polynomials. We saw that how can we divide one polynomial with another polynomial and what are the conditions which should be satisfied for the division of two polynomials. For example, if a polynomial 2x squared plus 3x plus 2 is given to us and we have to divide this polynomial by another polynomial which is x plus 1. On dividing, we get remainder equals to 1 and quotient equals to 2x plus 1. Means if we divide one polynomial by another polynomial, we can find remainder and quotient as well. But if we are only concerned with the remainder, that if we divide one polynomial by another polynomial, then what will be the remainder? We are not concerned with the quotient. We also need to find the value of remainder on division of one polynomial by another polynomial. For that, we have a shorter way, which is remainder theorem. Remainder theorem enables us to find remainder when one polynomial is divided by another polynomial. So our topic for today is remainder theorem. Firstly, we will discuss about remainder theorem. Then by using remainder theorem, we will find the remainder when we divide 2x squared plus 3x plus 2 by x plus 1. Obviously, we will find remainder 1 in that case as well, but it will help us to verify our answer. So let us start with the statement of remainder theorem first. Remainder theorem states that let Px is any polynomial of degree greater than or equals to 1, means Px may be a linear polynomial, it may be quadratic, it may be cubic polynomial, or it may be biquadratic polynomial. Means Px should be a polynomial of degree either greater than 0 or equals to 0. And let a be any real number, a is any real number, such that x minus a is a linear polynomial. If we divide given polynomial Px by the linear polynomial x minus a, then according to remainder theorem, remainder is given by P of a. So students, first thing that you need to mind is remainder theorem helps us to find remainder when given polynomial of degree 1 or greater than 1 is divided by a linear polynomial only. Means dividend may be a linear polynomial or a polynomial degree greater than 1, but divisor should be a linear polynomial only. Let us try to understand with an example. Let Px is any polynomial such that degree of Px is greater than or equals to 1. When Px is divided by x minus 1 over 2, it may be any real number, but we know that 1 over 2 is also a real number. That's why we have chosen x minus 1 over 2. When polynomial Px is divided by x minus 1 over 2. So one thing is clear, that Px is dividend and x minus 1 over 2 is divisor. So when we are interested to find remainder by using remainder theorem, what we have to do? We will put divisor equals to 0. So if we put x minus 1 over 2 equals to 0, the value of x will become 1 over 2. So whatever the value of x becomes, that value should be put in the dividend. Means we have to find the value of dividend for x equals to 1 over 2. Then after solve it, so whatsoever the value of p of 1 over 2 comes, that will be the remainder. Now we will do one question in this regarding. Let us do this question only, that find remainder when 2x squared plus 3x plus 2 is divided by x plus 1. Well students, we will use remainder theorem to find the remainder. So let us suppose that the given polynomial or the dividend is p of x. Let p of x equals to 2x square plus 3x plus 2. Then we write when px is divided by x plus 1, then by remainder theorem remainder is so as per the things which we have discussed here, we will put divisor equals to 0. Here divisor is x plus 1 because px is divided by x plus 1. That is why x plus 1 becomes a divisor. We will put divisor equals to 0. From here the value of x will become minus 1. We don't need to show this in fair. We can just do this in rough work, or if you just can do it verbally, that will also be fine. So we will put x equals to minus 1 in the given polynomial. P of minus 1. Now we will put value of x equals to minus 1 in the polynomial. Since polynomial is 2x square plus 3x plus 2, that's why I am going to replace x by minus 1 in left hand side as well as in right hand side. So right hand side will become 2 of minus 1 the square plus 3 into minus 1 plus 2. Now we will find the value of this polynomial for x equals to minus 1, and on solving it will become 2 into 1 minus 3 plus 2, that is 2 minus 3 plus 2, it will become minus 1, and on solving it will become minus 1, which is our remainder. So by using remainder theorem, remainder becomes 1. And even by long division, we had remainder 1 only. That is how we can verify remainder theorem. Now students, you have understood that what is the remainder theorem and where it is used. Now we will do the proof of remainder theorem. Usually what we do, first of all, we do theorems, we do proof for the theorems, then after we move to the question part. But here firstly we have done question and now we will do proof of the theorem. It is because now theorem is verified, because we have seen that if we divide one polynomial by some other polynomial and find remainder, that will be the same as we have found in the remainder theorem. So you are clear that remainder theorem is valid and it is verified. Since it is verified, so it will be easier for you to understand the proof of the remainder theorem. So let us start with the proof of remainder theorem. Let px be any polynomial with degree greater than equals to 1 and x minus a is any linear polynomial where a is any real number. And we know that when px is divided by x minus a, px is dividend, x minus a is divisor. So it is clear that when we divide px by x minus a, there will be some remainder and quotient as well. So let us suppose that when Px is divided by x minus a. Let quotient is q of x and remainder is r of x. Since polynomial is in terms of x, this is the polynomial in one variable which is x. That's why quotient and remainder, they will also be in terms of variable x only. They may be constant as well, but if there is variable, that will be only x. So now Px is dividend, x minus a is divisor, Qx is quotient and Rx is remainder. And we know that by division algorithm. Dividend equals to divisor into quotient plus remainder. And we know that dividend is Px, dividend is P of x, divisor x minus a, quotient q of x and remainder is r of x, where degree of remainder should always be less than the degree of divisor. Since we know that degree of remainder should always be less than the degree of divisor. Since degree of divisor is 1, so it is obvious that degree of remainder will be less than 1. That is, degree of remainder will be 0. Or we can say that remainder will be a constant polynomial. So better we should write remainder as r only. Again, since degree of remainder is always less than the degree of divisor, and here the degree of divisor is 1, so degree of remainder will be 0. That's why we have written r of x as r, which depicts the constant polynomial. So accordingly, we get p of x equals to x plus a into qx plus r. Now p of x is x minus a into qx plus r, and if we go for the particular case, in particular means if we choose a particular case when the value of x is equals to a, so we should replace x by a in the whole equation. So on doing this, we get p of a equals to replace x by a minus a into q of a plus r. This implies p of a equals to a minus a is 0, 0 into q of a plus r, 0 into something, that will become 0. That is how p of a will become equals to r. Or we can say that remainder is given by p of a, which proves the theorem. Because in the statement of remainder theorem, it is given that if px is any polynomial of the degree greater than or equals to 1, and px is divided by a linear polynomial x minus a, where a is any real number, then remainder is given by p of a. That's it. In next session, we will discuss about factor theorem, which is the application part of remainder theorem. Thank you.